Hello everyone, welcome to the channel. Today we are going to solve the problem LeetCode question number 3770, which is the largest prime from the consecutive prime sum. Okay, this question came into the LeetCode weekly contest 479, and this is a question number second. Okay, so let's jump into and let's see what they are saying. So what are they? You are given an integer n. Okay, return the largest prime number less than or equal to n that can be expressed as the sum of one of or more consecutive prime numbers starting from 2. If no such number, return the 0. Okay, so let's understand what they are saying. First of all, I think you should know what is the prime number. Prime number is that the number that is only divisible by 1 and itself. Okay, that is called prime number. Let's see some of the example of the prime number. Okay, so one is 1 because 1 is divisible by 1 and itself. Then second one is this 2 is divisible by 1 and 2 itself. Okay, then next one is 3 is divisible by 1 and 3 itself. Okay, and next one is 5, then 7, then 11, and list goes on and on. Okay, because you can easily see all of these number are divisible by 1 or itself. None of the number can divide this number. Okay, so I hope you understand what is the prime number. Okay, so let's understand what they are saying. So they give us a integer n. Okay, actually let's see an example. Okay, so here n is value is 2. Okay, so we have to return the largest prime number which is less than is equal to no. Okay, so we have to return the prime number, the largest prime number which is smaller than is equal to n. Okay, we have to return that number. Okay, but we have to condition something. What's that condition? That can be expressed as the sum of one or more consecutive prime numbers starting from 2. Okay, so first list down all okay, first to better understand, list down all the prime number that comes under the 20. Okay, so first one is start from 2. Okay, 2, then 3, then 5, then 7, then again we can say 11, then 13, then 17, then 19. So these are all the prime numbers that come under the that is less than is equal to n. Okay, so here we can see output is 17. Okay, but 19 could be our answer because 19 is greater than n, and this is the it is the closest from the n, I mean the 20 numbers, 20th. Okay, so why 17 our the answer? Because we have to choose the specific prime number which itself sum of the consecutive prime numbers. Here you can see the example. Oh, why in this range of 1 to 20, these three are the prime numbers that are the consecutive sum of other prime numbers. Okay, let's take an example of 2. 2 is a sum of only 2. We already see in the question we have to start from the 2 everything. Okay, another one is 5. 5 is a sum of 2 plus 3. Okay, and 2 is a prime number and 3 is also a prime number, that's why it's count as the answer, but we have to find the maximum one. Okay, so let's give look at the another one. Let's take the 7. Okay, if you took the 7, then 7 is a sum of 4 plus 3. So you can 3 is a prime number but 4 is not a prime number, so we can't take this 7 as our example. Okay, let's look the another one. Let's take the example 11. Okay, what 11 11 is a, let's suppose, a sum of 6 plus 5. Okay, and 5 is a prime number but 6 isn't a prime number. And one thing I told you about this question, I miss here. So let's take a example 7 again. Okay, 7 again. We have to take consecutive prime numbers, my 1 by 1 by 1, that's this one, 2 3 5 7, 1 by 1, and we have to start from the 2. Okay, can we convert make 7 from start from 7? start from 2. Okay, let's check it. Let's go start with 2. Okay, we put it 2. Then what are the next number is 3, put it 3. Then what are the next number is a 5. What are the sum? Let's check the sum. 2 plus 3 5, and then 5 plus 5, what are the 5 plus 5 is equal to 10. Oh, so what you get? We couldn't make 7 from the consecutive prime numbers. We can clearly say 2 plus 3 plus 5 is equal to 10. We cannot make this 7. So 7 could not be the answer of our question, or answer of this question. Okay, so let's jump to the explanation part. Here we can see the 17 is our answer, because 17 is the largest one, and 17 can make from 2 plus 3 plus 5 plus 7. You can look at there, 2 3 5 7, these are the consecutive from the 2. Okay, consecutive from the 2. So I hope you understand why, what is the question says, what the requirement. Okay, so let's jump to the explanation how we can solve this question. Okay, so first of all, I want you to try this question by yourself. Okay, I want you to try this question by yourself. You can clearly, what you can do is, you can clearly check each number 1 to n, and some of them, check if this is a prime number or not, and consecutive sum, and check. Okay, you can try this. Okay, I want you to play, at least you try that method. That is a brute force method. We can check each and every number to n, is this a prime, and some of them number. Okay, I know this is a brute force, and if you do that, you definitely get a time limit exceed. Okay, time limit exceed error, because you cannot complete this question with those method, because it's a very high number. We cannot, constraint is very high. You cannot complete this, because if you check the prime, you hope how to check the prime number. You have to again calculate from 1 to till n number and check the prime numbers between them. Okay, what are the prime numbers, is that is a prime number or not. We have to check each and every number between 1 to till n, is it divisible by another number or not. If it is divisible, that it is not a prime number. So we have to check everything. So that's is a very big time complexity. Okay, so let's jump to the optimal solution that works in this case. So if you, in this question, you definitely going to learn something new. Okay, so what is the new thing that you're going to learn in this question is this one, the Sieve of Eratosthenes. I don't know how to pronounce this, but I hope you understand what they're saying. So what we are getting from this thing, what they are what they provide us is, this thing provide us all the prime numbers between 2 till n, all the prime numbers between 2 till n. Okay, so it helps us very much, because if you iterate from 2 till n, we didn't check every number it is a prime or not. We just go through actually we are creating an array, and we can just check if this is a prime number or not, or it just give us the answer what are the prime number. Okay, so first understand the Sieve of Eratosthenes. What is this called, I don't know. Okay, so let's check this, how we implement this thing. Okay, how we implement this thing. So first we are creating a array, you can clearly see, and we are creating the array of n plus 1. Why we are creating the array of n plus 1? Because we are taking every index as a number. Okay, here it is 7 index, is a represent the 7th number. You can clearly see I create an array of 0 to 20. Okay, which is a size of n plus 1. I hope you understand why we are taking the n plus 1. Okay, let's start. Okay, so start from here. Okay, so we are starting from 2. We just ignore the 0 and 1. Okay, just ignore this thing. We start from 2. Whenever we start, what we are doing is, we set everyone as a prime number. Okay, we take an example, we create an array till 0 to that number, n number, or we set each and every number as a prime number, and we eliminate every time which are not a prime number. If you are confused, let's start and we get. Okay, so first what we are going to do is, we are check a number which is from 2 to till 20 as a prime number, we consider as prime number right now. Okay, so what we are going to is, we can set is a true also, or we can set as true, or we can also use that here as a 0 or 1 number. Okay, so let's go with 1 or 0. Okay, so we put every element marked as 1. Okay, so we put 1 here, 1 here, 1 here, 1 here, 1 1 1 1 1 1 1. Okay, so we put 1 at every element. Okay, so what this 1 represent us, this 1 represent us, this is a prime number. Okay, so you are gonna say, is this for a prime number? Of course not, this is not a prime number. So that's what we are doing in the next step. We are eliminate all the non-primary number. Okay, we eliminate all the non-primary number. So how you're going to eliminate we are again calculating each number, is this a prime or not, and then mark it? No, we are not going to do that. Okay, so how you're going to do that, how this thing is work is, I put here, we start from 2. Okay, let's take 2. Okay, and we divide 2 by 2. We want to multiply, what we are, this is give a 4. We again 2 into 3, this is gonna 6, 2 into 4, this is gonna 8. Okay, so we are keep going this. Okay, we are keep going this. So whatever we number this get, we are getting this number. Okay, we marked as a non-primary number because we get 8 by what, 2 into 4. We already know prime number is not a factor of anything. Okay, it's by itself, accept itself. Okay, so how you, if 8 come by 2 into 4, then definitely 8 is not a prime number. Okay, because 8 is divisible by 2, or 8 is also divisible by 4. So 8 definitely not going to be prime number. So we are eliminate those number. So we are starting from 2. Okay, so let's start from 2. Okay, let's start from 2. Okay, so 2 we put after the 2. Okay, yani 2 into 2, not pick the 2 into 1. Okay, so 2 into 2, 4. So this is not a prime number. 2 into 3, 6, not a prime number. We marked as a 0. Okay, we marked as a 0. 2 into 4 is not a prime number again. We marked as a 0. Then 10, 0. Then 12, 0. Then 14, 0. Then 16, then 0. Then 18, 0. And then 20 and 0. Okay, so we eliminate all the prime number which are divisible by 2. That means these are not a, all of these 4, 6, 8 are not a prime number anymore. So we still have a prime number. What we are doing, we jump to the next number is 3, and we do the same thing which are doing with the 3. We put all the number which are divisible by 3. So 3 into 2 is equal to 6, 3 into 3 is equal to 9, and the 3 into 4 is equal to 12, and it goes on and on. Okay, so let's mark it. Okay, so 3 into 2, 6, already marked. Okay, 3, then 9, let's mark it. Then 12, already marked. Then 15, mark it. Then comes to the in 18, already marked. Then we don't have, we are not enough numbers. Okay, then we again do the same thing with the 4, 5, 6, and goes. Okay, but so after all of this, we eliminate all the non-primary number from this array. Okay, and we only get all the number we marked as 1 which are the prime numbers. Okay, so how we are going to do this? And again we gonna one thing that we are going, you are going to confuse, that we calculate with 2, we calculate with 3. What are the next number? You think it's a 4? No, we are calculating with that number which are already a prime, which is a 5. We are not going to divide all the number with our 4. We are going to use 5 because 5 is marked as a prime right now. Okay, right now this 5 is marked as a prime. So we are divide actually multiply the numbers with the prime numbers. And okay, I hope you understand what I am trying to saying that. Okay, so let's move. So we can also, we can also uh, to modify this thing all. Okay, so what you are doing is, we are doing here is, we iterate each and every array, so we don't need to iterate all of this number each and every time which are the prime. We just need to iterate till the root of n. Okay, root of 20. Okay, so how you are going to do this? So why we put is root into n? Okay, if you come here, okay, I I will show you something. Okay, so here you can see that 2 into 3 is equal to 6. Okay, we mark 6 that this is not a prime number. But if you again, if you start from 3, here you again see 3 into 2 is a 6. We already marked it, this is not a prime number. Why we are calculating this thing? Okay, why we are calculating this thing? We don't require. Okay, so what we are doing, we always start from I into I. Okay, the 2 into 2 4, 3 into 3 9, 5 into 5 is equal to 25. Okay, so always start from square till the root n. Why we are using root n? You are saying that. Okay, let's suppose you start from 2 3, then you come to the 5 because you skip 5 4 because it's not a prime number. What happened when I told you we are using start from I into I? What happened if you use this thing here? If you come here and if you do 5 into 5, it's go to the 25. If comes to the, it goes to the 25. This gives you error of index out of bound, because we have only the 20, length is 20, not a, no, we have only index till the 20, not 25, so it gives you error. So we only calculate till the n, root of n. Okay, you can understand why we took n, root of n. Okay, you can clearly see. So let's jump to the coding part. I hope you understand. If you come here, if you create this array, if you are able to create this array where you find all the array prime numbers and non-prime numbers. Okay, this array will directly tell you is this a prime number or not. So what our task left remain is basically very easy. We have to put those prime number which are consecutive sum. Okay, which are consecutive sum, we have to put those prime number, return those prime number which are consecutive sum. So how you're going to do this? This is a very easy part. I will show you in the coding part, or we can already show this here. What I'm going to do is, we are actually creating a for loop. Okay, actually creating a for loop. Okay, till from the 2 to n, and we are check that, and we take two integer. First one is the sum, and initially it's a 0. The second one is our result. Okay, which is initially 0. Okay, we starting from the 2. Okay, and what we are going to do is, we add 2 in this sum. Okay, so sum is equal to, so our sum is become to the become 2. Okay, is this 2 a prime number? Is this 2 a prime number? We check that. If this is a prime number, then we add it to the result. Okay, so yeah, we mark this sum as a 2, and if we are going to check is this 2, we're going to check two thing. Is this sum is a prime number or not? Okay, and another thing what you're going to check is this sum is less than is equal to n. Okay, if this condition is true, that means these are our potential answer. This thing becomes our potential. So we put this sum, we put this sum value into our result value. Okay, is equal to result value, because this can become our potential result. Okay, I hope you understand how this come. Okay, because you, in this question they said that we have to start from 2, so we put every number here, 2 plus 3 plus, if I told you, let's suppose 2 plus 3 become 5. okay, become 5. 5 is a prime number, yes, it's a prime number. Then we add this thing, and it's also less than 20. Hope you understand. Then what we are going to do, we're going to again add is 5. So what become, it's become the 10. 10 is a prime number, no, it's not a prime number, and it's not so it cannot become our answer. Then next number, what is our next prime number, is a 7, okay, it's a 7. And then it's become the 7, and 17 is also less than 20. Then what's the next prime number, it's a 11. Then whatever the it's become the 28. 20 is greater than 20, so it cannot be, so we break here, we don't know, need to calculate more. And one more thing I forget about here, we only add those number, you can clearly see here, you can clearly say we only add those number which are the prime number already, okay. So how you gonna check this is a prime number or not, we calculate from 2 to n, we calculate from 2 3 4 5, then 6, and we ask our array, this array this array, is this a prime number or not. We will ask this, hey array of, we can go, what we can do is we can create array, and we ask from this 2, is this 2 a prime number, if it is prime number then we gonna add. Is this 3 is a prime number, no, we don't gonna add this number. Is this 4 a prime, yes, it's a, sorry, 3 is a prime number. Is this a 4 a prime number, no, it's not a prime number, so we are not gonna add this number, okay. So see, we have do this. Let's jump to the coding part, and we can see how we do this. If you are not don't know the Java, you can easily understand what we are doing here, and you can code this on your own, at your own language, okay. So first we are creating the num array at the size of 1, because we first need to create this thing we have first need to create this array which we are gonna this array tell us which is the prime number or not, okay. So again, with 2 till n, okay, and mark it 1. I already told you, we all mark every number as a prime number. Then after next iteration, we mark all those numbers which are not a prime number. We are starting from 2 till the math square root of n. Why we have put square root of n, I already told you here. Why we are picking root n, because we are starting from 2 into n, 3 into 3, 2 into 2, 3 into 3, 4 into 4, 5 into 5, okay. So here we can clearly see, if you start from 5 into 5, it's become the 25, it's exceed the, it's give you the error, array index out of bound, okay. So why that's why we are put we are iterate till the root of n, okay. We iterate through the root of n, and we only iterate which that is already prime, okay. You can see j is equal to I into I till goes to the minus n, and then j plus is equal to again I, because you can clearly see 2 plus 2 4, which are already I into I. Then again I plus 2, what is 6, then 6 plus I is 8. Similarly goes here, plus I is 9, then plus I is equal to 12, and this thing goes and goes and goes, okay. So after creating that array, we are creating that nums, we are iterate through this array, okay, our main array. So we are creating two integer sum, and then result. In a sum we add all those the prime number, and in a result we add the potential answers which is already a prime number, that's sum. So again we start from the 2, and what we're gonna, if this you're gonna check nums of I is equal to 1, that means if nums of I of is equal to is a prime, and that's and if that number, if we add that, if this number we can add into, is this a less than smaller than n, then what we are going to do is we add those number in a sum, and then what we are going to, again we are going to check this, if nums of sum, if the if this number, if the sum number is a prime, then we can add this at the result, and at the end we return result, okay. I hope you understand what I am trying to say. Let me know in the comment what can I improve here. I'm just starting, I hope you're gonna learn. If you have any doubt, please let me know in the comment, okay. So that's it from today's video.